Linear functions. So we have a function f is linear if it fits this format, and they have real numbers a and b. A cannot equal 0. The domain and range of linear functions are negative infinity to positive infinity because it makes a straight line. Okay, so we've talked a little bit about intercepts before. It says graph the function using intercepts. It specifically told us to use intercepts. So we're going to use our find x-intercept, let y equal 0, to find the y-intercept, let x equal 0, plot this over here, and then determine the domain and range. So the first thing we're going to do is let y equal 0. So recall, f of x means the same thing as y equals, so say 0 is equal to 3 over 2x plus 3. So I'm solving for x, I subtract 3 from both sides. And that would give me this. And then when I'm trying to get x by itself, I can multiply by the reciprocal, which is 2 over 3. There's more than one way to do this, but times 2 over 3. And then that would all reduce out, it cross cancels. And then what I'm left with is my left-hand side, which if you cancel, divide by 3, divide by 3, I would just have 2 times negative 1 is negative 2 over 1, which is just negative 2. So I would have the ordered pair negative 2, 0, which is right there. Okay, so now let's go back and find the y-intercept, and we're going to let x equal 0. So get y equals 3 over 2. Let's let x equal 0. So this one's much easier. We just get y equals 3. So the order pair is 0, 3, which is here. And we sketch our graph. Now we name our domain. Your domain is your x values, and it's your leftmost, which is an arrow, to the rightmost point, which is another arrow, so negative infinity to positive. The range is talking about your y values. It's the bottommost to the topmost. And not only that, by definition, we said it was negative infinity to positive infinity. The constant function, where f is constant, is f of x equals b. The domain's negative infinity to positive, and the range is b. So graph of a constant function is a horizontal line. And we look specifically at these particular ones. So f of x equals negative 3. That's going to be a horizontal line at negative 3. So negative 1, negative 2. Okay, so here, and it's going to be a horizontal line. So that's what it looks like. Your domain will be your leftmost to your rightmost values. The range is your bottom to the top, but in this particular case, it's just negative 3. Graph x is equal to 4. That's going to be a vertical line at 4. Assume that's a straight line. X equals 4. Okay. The domain is going to be the x values, left to right. The range is the y values, bottom to top. So that's our graph of our x equals 4 equation. We're going to make mention of standard form of an equation, but we're really going to talk about it more later when we're working with equations of lines. But basically, be familiar with it's in the format ax plus by equals c, and you want your a term, you don't want it to be a fraction or a negative. So we're given this equation, 2x plus 3y equals 0. It's a standard form equation, and they're telling us to graph it. So what we're going to do is we're just going to graph it using x and y intercepts this time, give the domain and range, and we're going to talk a little more extensively about standard form later. So let's let x equal 0, 2 times 0 plus 3y equals 0. So we would get 0 plus 3y equals 0. Divide both sides by 3, and y equals 0. So when x was 0, y was 0. Okay, now let's find the other intercept. To find the x-intercept, we're going to let y equal 0. So we have 2x plus 3 times 0, 2x plus 0, 3 times 0 is 0, and then now we just divide both sides by 2, and we get x equals 0. For this one, we got the same exact point. So in this case, our graph goes to the origin because the x-intercept is 0, 0, and the y-intercept is 0, 0. So we just need one other point to be able to make this graph. We can choose anything we want. Let's just let x equal 6. So 2 times 6, and I'm getting this from this equation, 2 times 6 plus 3y equals 0. And then I'm just solving this thing algebraically. Solve for the missing variable. So I would get 3y equals negative 12. Divide both sides by 3, and y equals negative 4. So that was when x was 6, y was negative 4. So let's go over 6, down 1 here, and then we will draw our line as best as we can through that. And there's your graph of your equation. So we usually try to start with x and y intercepts, but in this case we needed another point because they were the same. The next concept we're going to talk about is slope. And slope is the steepness of our lines. And it's given by, if you're given a graph, we usually calculate the rise over the run. This is delta y over delta x, and it just means change in y over change in x. This is our most often used format. It's given 2 points, and we use our formula. And it says where delta x cannot equal 0. Okay, it makes no difference in which point you call x1, y1 or x2, y2, but you must be consistent. A line with a positive slope rises to the left to right, so this would be a positive slope. A line with a negative slope falls left to right, so a line that would look like that would be a negative slope. A vertical line, we talked about before, is undefined. It has an undefined slope. It's a vertical line. And then the last one, a horizontal line, has a slope of 0, has no steepness. So those are the 4 cases. You can have examples by those. And the next thing we're going to do is we're going to be asked to calculate. It says find the slope of the line given 2 points. So given 2 points, we're going to use this formula right here. So I'll leave us some room so we could still see it. We're going to do slope is equal to y2 minus y1 over x2 minus x1. So y2 is negative 3 minus y1 is a negative 1. x2 is negative 3 right here minus y2, which is going to be negative 2. That becomes plus, so we get negative 2 over negative 5. A negative divided by a negative is a positive 2/5 slope. Alright, and we'll look at B. y2 minus y1, x2 minus x1. And I didn't label them in the last one, but if it helps you to label x1, y1, excuse me, x1, y1, it's sloppy. x1, y1, x2, y2, then you can do that. So it's 9 minus 9 over negative 1 minus 5, and 9 minus 9 is 0, over negative 6. This is going to be slope of 0, which we set up here as a horizontal line. But all they asked us about in this particular case is just the slope.